This was just luck. They were going down the path of life shortening, trying to introduce it, and then hit this barrier that the stronger the transmission blocking through life shortening, the more difficult it was to get this parasite to spread. And then they happened across this other strain where it was like, well, wait a minute, this doesn't incur the same fitness costs, but actually blocks transmission, and that one's much easier to spread.
And so has that actually been used at all now?
So so there's a big program trying to. There have been sort of experimental field level releases. So the project scaled through small lab studies, through to big greenhouse cage studies, through to experimental releases in Australia, in a number of locations in Cairns, and now spreading from that into 5 countries, trying to build up the capacity and go through introductions and actually try and do the big experiment. Let's throw these things out of the door. It's kind of an interesting approach to doing the project as well, in that it's well founded, there's good evidence base here, but at a certain point you just got to throw it out the door. Is it going to work or not? We can't research everything forever. There's a real tension here. 5 years research, 10 years research, 15 years research. When are we going to throw it out the door? When are we going to start saving lives? They came up with sufficient evidence that they thought it was going to work, it was going to be sufficiently safe, and they're throwing it out of the door.
Fingers crossed.
Fingers crossed.
So there's one very interesting finding when they've done that in Cairns. They've been able to release it in an area and it's spread. And then when it gets to major roads, it doesn't spread over it. And that's because the mosquitoes don't fly over the road, is that right?
Yeah, so these mosquitoes...
It's not a joke.
No, it's not a joke.
Why did the mosquito go on the road?
Is it or am I wrong?
Chicken.
No.
Yeah, the chickens. Chikungunya doesn't cross the road.
So... Pete.
You gotta put up with the bad jokes.
Aedes aegypti is a very local mosquito, and it leads to very, very marked heterogeneities in transmission. Very closely associated with people's houses. So they'll breed in containers and flower pots and upturned buckets and such like. And so you can, in areas where people have tracked the epidemiology, you can see very, very local household level transmissions. The mosquito doesn't fly very far. So when you come up against a major barrier, whether it's a road or an area which isn't populated by people in appropriate breeding size, then that can actually stop the spread. So it's a real challenge for how you're going to do the release as to where, and this is one of the major research issues at the moment, is even though Wolbachia has the capacity to spread, you've still got to introduce sufficient numbers to sort of get it over an introduction hurdle. You need, if it's just one mosquito, chances are it's just going to fail. It's going to peter out, peter out. And you need to introduce enough relative to the background population to get it to take. And so it's not clear whether, and to do that in one location where things are very, very highly mixed and the mosquitoes move around a lot, then you could imagine, well, I'm just going to pick a number. You could release, a million mosquitoes out the door, and that will cause it to spread. But if it's very heterogeneous and doesn't spread, you might have to introduce sort of 100,000 here, 100,000 here, 100,000 here, 100,000 here, 100,000 here, and that's a very difficult and different introduction strategy than just driving along the street, opening the back of the van and throwing your insects out. And that's what you do with biocontrol. People have done that for introducing parasites to control insect pests. It's an interesting strategy. What's the best way of introducing mosquitoes? Introducing these predators or these parasites? Do you introduce 100,000? Do you introduce 10 lots of 10,000? 10,000 lots of 10, or whatever the math is? And that's an interesting challenge. And in biocontrol, for in cases. Sometimes it's just been introducing a handful has allowed these parasites to establish and spread these parasitoids. Other times it's been mass inundation and literally throwing things out of the back of aircraft. And I don't think we know with Wolbachia where we are in that at the moment. And that's
as we've seen with I think a lot of the control issues in this course and a lot of the topics we've discussed, there's their fundamental biological questions that have to be solved, but also really strong operational questions. And unfortunately, those things we don't often know until we actually put these things out into the field and try to resolve them.
The public relations challenge of dumping one of the numbers you gave, millions of mosquitoes in our neighborhood, and then all of a sudden everybody gets bitten. That seems to be an interesting public relations problem with some of these ways to operationalize.
Don't worry, your grandchildren won't get
right? I mean, we've talked about that people won't get a vaccine if we're talking about the pain. That's a whole lot of mosquitoes in the neighborhood. That has to be quite a challenge.
Yep. So the Australian group, where they've done this in Cairns, and now as they're spreading into different countries, they are fully aware of this. I mean, first of all, you're introducing mosquitoes, which is there's and
not
actually
everybody's favorite.
whether you call them genetically modified or not,
Right.
actually these aren't. They're transinfected with a parasite, but nonetheless there are techniques which include genetic modification. So you've got concerns over release of a GM organism and then throwing mosquitoes out the door too. So it does require absolutely very big community participation and community buy-in. There are techniques where you can just introduce the male mosquitoes, and so these have some attraction because you're not bitten by these. So in terms of community acceptance, that's much easier. And of course, these are all lab-bred, so you're not introducing parasites. But even so, it is a big deal. But then people don't like being bitten by mosquitoes either. So
this to put out your
but
personal repellent that they can use.
But I do think there's some interesting parallels with vaccination here.
Yeah.
People are right up for vaccines when the disease is in their face. And so if you're saying we're going to release mosquitoes to contain dengue that's killing you, people take it seriously. If you try to release mosquitoes in an area where there's not much disease, sure, you got these problems. But disease motivates people enormously.
No, I'm sure that's right. I'm sure it would be, as you talked about, the differences of elimination and eradication. If there's not anything going on and you dump 100,000 mosquitoes, you make up the number. That number is also compelling, right? 100,000 of anything, regardless of mosquito.
And I think it's the same with genetically modified organisms.
Yeah,
People get very tense about GMO when it's not solving an immediate problem. If your children are dying of malaria, GMO is low down the list of concerns.
But you wonder about the scare factor. So, for example, if you suddenly said, we will give free Ebola vaccinations to anybody who comes to their doctor or comes to CV or whatever the pharmacy is tomorrow, I just wonder how many Americans, given that the likelihood of them ever getting it is far less than being hit by lightning or, I read a wonderful, it's far less than actually dying from your pajamas setting light the other day. You're far less likely to get Ebola. But you wonder if people would do that.
you mean set fire to their pajamas? Or,
We have to stop there.
I think we're surely.